So welcome everybody. Thanks for the introduction, Amy. As she said, I'll be talking about building a scalable elastic cluster on AWS in 5 steps. And I have a lot of material to cover and I want to leave time for questions, so I'm really going to zoom through this stuff, okay? So let's get started. Why do you need a cluster in the first place? Well, you have too many users for a single server. That's the first reason. You can scale up pretty large with Alfresco with a single server, but if you have tens of thousands of users, you probably want a cluster. Another good reason would be if your business is very in need of high availability. You need to be on all the time. So you want the security of if one server goes down, you still have a working instance of Alfresco up. Another reason might be if you have users that are geographically disparate, as in maybe you have a California office and a New York office. That's probably not really what you'd want to do a cluster for. You're probably better off doing a read replication rather than a cluster for that. So let's dive into what exactly a cluster is and what it looks like. This is the typical Alfresco cluster architecture from the wiki or the documentation. What you have is a load balancer in front of the form and web servers, and then you're talking to a shared database and a shared content store. Your indexes are synced up with the L2 cache replication, which makes sure that you can search and everything is consistent across your nodes in your cluster. So what this looks like in terms of AWS is an elastic load balancer in front of an auto-scaling group with S3 for your shared storage and RDS for your database. And I'm going to dive into all of these in more detail. So what do we need to do this? This is our 5 steps. We've got a shared content store. We're going to use S3 for that. S3 is a great choice because it doesn't require a lot of setup or setting up a cluster or something like that. It's highly durable also. The biggest problem with it is it has a lot of latency. So we'll address that as well. For database, we're going to use RDS. As Simone talked about earlier, RDS is a managed relational database system. You have the options of using MySQL Oracle or SQL Server, all of which Alfresco supports. So step 3, we're going to build a cluster AMI. That's an Amazon machine image. It's basically your template from which all of your nodes in your cluster will be built from. The catch there is we need to know what's going to happen at boot time so that the node that just starts up can join the cluster. Step 4 is going to be a load balancer. It's pretty easy to set that up, but takes a little bit of configuration to do it. And then finally, we'll set up the auto-scaling group. The great thing about auto-scaling is you can scale up or down capacity. So if you have momentary spikes or a couple hours a day where you have a lot of usage, you can scale up for that and then scale down the rest of the time and cut back your costs. So first of all, we'll dive into the S3 part of this. S3 is great. Again, you can use any size content store, essentially, files up to 5 terabytes in size. Like I said, it does have some latency. For this, I used Louis Sala's Alfresco Cloud Store project, which is out there on Google Code. I did have to do some work to that to make it work with 4.x. It worked fine with 3.x. In order to make it work, you can go up there and download the AMP files that are already created, but if you want to build it yourself, you'll need to edit the build.xml and set some properties. Then you'll obviously build and deploy it, make some changes to your Alfresco global properties, and then create a bucket in S3 for your content store. Then the Cloud Store project is configured with a cache and content store, and this is how we deal with latency. A cache and content store will let you keep your content locally, and then as it's needed, it will go out to S3. So anything that's used more frequently will get pulled onto your local content store where it's much faster, lower latency. So this is all available in the Cloud Store project, but the readme.txt has all the information about which property files to set, the Alfresco install dir, where Alfresco is installed on your local system. And this is in the build.xml, which is what I'm talking about. Your Alfresco source store is where your SDK or Alfresco source code is located. And if you've not checked everything out from SVN, you'll need to change the Alfresco libdir and the war.file. Again, this is pretty straightforward. It's all in the README. But then after you do that, you can build the source code to the war file, automatically deploy into the war file, or you can build an AMP file if you have to deploy to another server. And of course, you need to be able to talk to S3, so you'll need to add your S3 secret key and access key so that the content can actually, well, the connector can talk to the content store that you just created, your bucket, and your S3 bucket name, where you'll keep your content. So you don't actually need to create the bucket. It'll create one automatically if it's not there. The caching content store, this is something that's out of the box with Alfresco. I didn't actually know that it was out there until I started playing around with this. But I think this is what Alfresco is using in front of their cloud instance. It lets you basically put a caching mechanism in front of any backing store, whether that's S3, your regular content store, or anything else that you've developed or otherwise. It's pretty much what it sounds like. You have a local store. It doesn't actually have to be local, but it would make sense to be local since it's caching. And then you can specify what size cache you want. And then there's some components that will clean up your cache if it gets too large. So, of course, you need to make some settings changes in your Alfresco global properties to do that. The main one is the dir cache content, which is the location on disk where you want to store your cache. The rest of this is all described on the Alfresco wiki. So I don't really want to go into it, but it's a bunch of settings that are sensibly defaulted and will manage how the cache works, how long things stay in the cache, that sort of thing. So next step is to set up the database. Like I said, we're going to use RDS for that. RDS also is a great option. It's a managed database hosted by Amazon. And it has some great features. It has the ability to replicate your content to another server. It has the ability to upgrade automatically point releases and also to do automatic backups. So you don't ever have to worry about backing up your database. It's done for you with RDS, or it can be. That's all optional. If you do decide to do those things, there is a chance that you will have some downtime if you're not using multiple availability zones for your RDS server. And that's because when you do a backup, it goes into a read-only mode. So your writes will definitely stop while you're doing a backup. And obviously when you're taking the server down for an upgrade, there's going to be some downtime, but multi-availability zone takes that away. So, real quick, this is what it looks like to launch an RDS server. This is the Amazon Web Services console, and this is the launch database instance wizard. You can see MySQL Oracle, other, what is that down there? SQL Server. So you can launch all kinds of different instances. Once you select what you're going to use, you can choose a license model, which version of MySQL or otherwise to start up, what instance size. This is showing an M1 small, but if you're doing this in production, you probably want something bigger than that. Depends on how big your cluster or Alfresco instance is. Whether to use multi-availability zone or not, whether to do the automatic version upgrades for your point releases, how big of a content store, not content store, but how big of a file system you want for your database. Again, Amazon has some good stuff where you can speed up your I/O by having a larger storage area where they essentially stripe the storage. So if you have 100 gigabytes or increments of that, you can get higher I/O throughput to your database. Finally, you'll set your name of your instance, your root password, and your root username. More configuration, you give it the name of the database that you want to start up. Which port number, if you don't want to use the default of 3306, you can change that. Whether to use virtual private cloud or not. Some of this is grayed out because I chose multi-availability zone earlier. So obviously you can't choose one if you're using multiple already. And then you can set a security group which controls who has access to your RDS instance, just like you would with an EC2 instance. Configuring backups. So you can choose to keep your backups for, I think it's up to 30 days, whether to do that automatically or not. And you can choose when to back up your instance and also when to do maintenance. And they'll give you a window here. It's not exactly when. Again, this doesn't necessarily matter so much if you're using multiple availability zones when you're starting up your RDS. Finally, you get to review everything and go ahead and start it up. So step 3, this is really the meat of the project. We're going to create a machine image from which all of our instances will be created and join this Alfresco cluster that we've generated. Again, S3 is going to be our content store, which all of those instances are going to be talking to. And then we'll have RDS as our shared database. So they'll all be talking to the same database, storing content in the same S3 store with a local cache. So the easy part, getting Alfresco installed. I used the WAR file to install rather than the installer. In doing that, I had to install everything individually, the JDK, Tomcat, OpenOffice, ImageMagick, SWF tools, etc. You don't really need to install MySQL, but it helps if you're trying to do some troubleshooting, talking to your database. Since we need the instances to know what's going on when they start up to join the cluster, we're going to talk to S3 and pull some information from S3 so we know where our database is, where, if any, instances are already in our cluster, and also Alfresco global properties. The reason I put Alfresco global properties in there is if you want to make a property change, you don't want to have to create a new machine image. So that's a little time consuming, and then you have to reset up all your auto-scaling groups and load balancers and that sort of thing. So it makes it a lot easier if you use if you put your properties file up in S3 as well. And of course, finally, we need to create a machine image to do this. So I used Ubuntu. If you're familiar with that, this should look pretty easy, but this is to install S3 Tools. S3 Tools is a utility that's not produced by Amazon or Alfresco, but it lets you talk to S3 from a command line, basically. And they maintain their own repository for Alfresco. I'm sorry, for S3 Tools. And of course, you need to go and get the signing key, add that to your sources list, and then configure and install the command. It's called S3 command. Real quickly, some of the commands that they have are, you have to run S3 command configure, which will let you set up your secret key and access key so that you can talk to your, your version of S3. The other commands are pretty straightforward. I don't know if I really need to go through them. You can list files, you can upload and download content from S3, delete, remove buckets, add buckets, that sort of thing. So I needed to create a startup script to go into S3 and get the information I need. This is a little bit of pseudocode to explain what I did. First of all, we needed to make sure that S3 was available. S3 command was configured on the instance. Then we go and grab our 3 files, our database configuration, our cluster configuration, our Alfresco global properties, move that to the right place in Tomcat shared, and then put our private IP address into there so that we could do the right thing with respect to the cluster. And I'm going to go through each of those files individually in just a minute, so we'll kind of see what's going on here. And then I have to put that information back up into S3 so that the next instance that starts knows where to connect to, so it can join the cluster rather than initiating a new cluster, essentially. And then since we're putting all that information back into S3, we need to remove it once it stops. So when the server shuts down, we'll remove our information from S3. So if you're not familiar with it, this is how you get your script to run at startup and shutdown. You put it in etc initd, make it executable with chmod, and then use this update rcd command. And defaults is actually part of the command. It's not a description. And that'll probably do the right thing unless you have a more custom installation. Starting up the script, running it at the right time during startup and shutdown. So obviously this needs to run before Tomcat, for example, so that you have the right configuration available then. So the DB config, pretty straightforward. This is just a little bit of an enhanced version of what's in the sample file of Alfresco Global Properties as it ships. We have the username, password, the location of the database, as in the server, and the port, and the name of the database to connect to. So our cluster settings, this is probably one of the interesting things about this project. We need to set up a cluster in Alfresco, and this is documented fairly well on the Alfresco wiki and in the documentation. But the most important thing to do, I suppose, is to set the Alfresco cluster name. Without setting that, no clustering will occur. So it can be whatever name you want it to be. It doesn't really matter what it is. It just needs to be there. In order to keep our indexes in sync, we've got the reindex missing content cron expression. I think that may be set a little bit too frequently, but it needs to be in there as well. You'll see that the Alfresco JGroups bind address is commented out. That is something that I am going to insert with my startup and shutdown script, so it's commented out here. Same with the Alfresco ehcache RMI hostname down at the bottom. The only other thing that's actually probably of interest here is the Alfresco JGroups default protocol. EC2 does not support UDP, which is the default from JGroups, so we need to set that as well. So I'll move along from there. And then Alfresco Global Properties, like I said, it's pretty much what comes out of the box, except for these couple things. The enhanced DB URL, which includes the location, the port, and the name of the database. The S3 things that we talked about earlier, the access key, the secret key, and the bucket name. And then the location of our cache and content store. Obviously, I ripped out the parts of the Alfresco Global Properties that are in the JGroups and the database configuration files. I'm just appending those together. That's the simplest way I thought to get to a whole Alfresco Global Properties. So in the end, you end up creating an AMI from that instance that you've been working on. This is from the Amazon Web Services console. Just right-click on your instance, create an AMI. You get to this wizard again, where you can pretty much accept the defaults here. You give it a name, description, and then the rest of it is configuring your storage, whether it's EBS instance or any other kind of storage that you've got on there. You can usually just accept the defaults there. One thing to note that when you create an AMI, it does actually reboot your instance, so don't expect it to remain running while you do that. Step 4 is our load balancer. This is pretty straightforward, but it's one of the most important steps, I think. Otherwise, you're just talking to instances. You don't have any single point to get to your cluster. So pretty straightforward. We're going to install the ELB API tools. This is the command line tools for working with load balancers. You can do a lot of this from the console, but by doing that, you lose the ability to script things in startup and shut down, through scripting and other tools that you've developed. In building an Alfresco cluster, you need to have sticky sessions set on the J session ID. This is not the default when you start up an ELB. It, by default, uses its own sessions, and that's not going to work with Alfresco. You'll end up having to log in all the time. So configuring the ELB tools is pretty straightforward. These are all also in the directions for setting up ELB when you download that. You'll need to have Java 1.5 or greater installed. You'll need to unzip the archive that has the ELB tools in it onto your machine, set the AWS ELB home to that directory where you unzipped everything. Of course, you'll need to have your Java home set. We add the bin directory so that these commands are all run as you start up. Not as you start up, but so they're available in the command line. And then last but not least, you'll need to set your credential file. This is again so that AWS can, you can get to your AWS account through your command line tools. There's a default credential file in there. There's actually multiple ways to set this up, but the credential file I thought was the easiest to do it. And then now to the meat of it. This is our first real AWS command. We're going to use the ELB Create LB command. Give it a name, my load balancer. When you set up a load balancer, there's different listeners, they call them, that you can configure. The listener, in this case, is on port 80, HTTP, and it's going to redirect to port 8080 on our instance side. So we'll talk to our load balancer on 80, and it will automatically redirect to 8080, which is what Tomcat listens to by default. And we don't have to mess around with anything on the instances to do that. And load balancers can work in multiple availability zones, so we specify the availability zone as well. Then we need to set the stickiness policy. So we use the ELB Create App Cookie Stickiness Policy. And one thing you can say for AWS is their commands are very descriptive, if not very short. But so pretty much the same thing. You'll get used to this command. You'll call the command, you give it a name, and then you set a policy name, which we will then later associate to the load balancer, and then the cookie name that we're going to use for our sticky sessions. So then we actually have to set that policy on the listener. We'll use the ELB set LB policies of listener command, give it our load balancer name, and then the policy name that we're going to follow, and then which port we're going to bind on. And since we're using 80, we'll use port 80. You can also set this up on SSL 443 and 8443 or whichever you desire, actually. So that's the load balancer. Next thing we'll do is get to the auto-scaling group. If you didn't want a scalable cluster, you could just stop right here and have your load balancer in front of instances, and you'd have an Alfresco cluster up and running. But the auto-scaling is, I think, the interesting part. In order to get that working, we need to create a launch configuration. This is essentially a template from which all of our instances are going to be created. It tells us what size of instance to run, what security group to drop into, and that sort of thing. Then we'll need to create an auto-scaling group. In order to make it an actual auto-scaling group, we'll need to define a couple of policies to scale up and scale down. And then we'll need to attach those policies to an alarm in CloudWatch to kick off the action to scale up and scale down. So again, diving down, we'll first install the auto-scaling command line tools. I'm not going to go over this slide in detail, just know that it's the same as before, except now you need to set the AWS auto-scaling home environment variable. So we'll start off by creating the launch config. And we'll use the AS create launch config command. Use the load balancer name, my launch config. You give it the image ID of the image that you're going to use as your template, which is what we created in step 3. Yeah. And then we say which type of instance we want to start up. In this case, M1 medium is probably not, again, what you'd use in production, but for testing purposes, you can easily make that scale up and down since it's small enough that you as an individual can force it to scale. The group is the security group that you're going to join. All of your instances will join this security group as they get started up from the auto-scaling group. And then whether you use monitoring or not, this is how frequently CloudWatch will give you metrics on your server. If you don't have monitoring, it's by default every 5 minutes. When it's detailed monitoring, you can go down to 1 minute increments. But detailed monitoring does have cost associated where when it's disabled, you don't have any cost associated with it. To create a security group, we want all of our instances to be able to talk to each other. So I've added the security group to both the ICMP, TCP, and UDP so that they can talk to each other with the J groups or whichever clustering mechanism. They have the ports open to each other so they can talk. Pretty straightforward, but this is maybe a good reference. You'll need to have port 8080 open as well. If you want to SSH 22, obviously. You really don't need to have 80 open, but if you wanted to do that redirect on your IP tables or whatever, you could do it there as well. Next, we need to create that auto-scaling group. We'll use the AS create auto-scaling group command, give it the group name, the launch configuration that we just created. That'll be our template for starting everything up. Which availability zones? Again, an auto-scaling group can span availability zones. So we'll use, in this case, just a single availability zone. And then the size of the cluster you want to start, minimum and maximum size. For these purposes, I used 1 and 3. And the health check, this is going to tell us when our servers are running or not running. If something goes wrong with the server, the health check should fail, and then a new server will take its place. So ELB is the load balancer. We'll use that for our health check, which actually delegates down to, not delegates down, but checks each server individually and tells us which ones aren't working. The grace period is, I'm thinking here, there's the grace period and the default cooldown. The default cooldown is how long to wait after a scaling action before you do another scaling action. And the grace period is how long after a server starts up before you will check it to see if it's healthy. So generally the health check will check like port 8080 or whichever port, check to make sure that HTTP is working. And you obviously need to have all of your daemons up and running. You have to have Tomcat up or whatever to make sure that works. So you need to have some time before it checks to see if it's healthy, before it shuts it down before it's even started up. And then you give it the load balancer that you're going to use in front of all of this auto-scaling group.
If I may note, the whole grace period thing is important because you want to avoid a Skynet situation where all of a sudden the ELB, basically the environment basically starts spinning up instances just because it doesn't think that Alfresco is up and running, and all of a sudden it's running 100 instances.
Right.
One hell of a bill.
Right. And luckily you can also put a maximum on that. So, but you could easily hit that maximum if you don't pay attention to the grace period. I've made that mistake before too. So then we need to create our policies. Again, this is the scaling up and scaling down policy. Pretty straightforward. We'll use the AS put scaling policy command, give it a name, in this case scale up and scale down. Our adjustment will be in number of servers, and that's because we're saying the type is a change in capacity rather than a percentage. You can also do a percentage adjustment. Note on the scale down policy, we're using a negative number, -1 server, so we're going to take away 1 server rather than adding 1 server when we hit this auto-scaling policy. And then, of course, we specify the auto-scaling group that that policy belongs to. And when you do this auto-scaling policy, you will get back what's called an ARN. And ARN is basically an identifier to our policy, which we'll need in order to attach it to a CloudWatch monitor. So it looks like that down there at the bottom. I've done all of this in a script to start up. It's a batch file, which I've made available as well. So you don't really have to worry about this. It's kind of done automatically for you. In order to do the last step, to attach the CloudWatch monitor to a policy, we'll need to install the CloudWatch command line tools. Again, same as before, except we need to set the AWS CloudWatch home variable rather than the other variables that we've set previously. So to set these alarms, this is where you've got some flexibility with your cluster. You get to choose a metric for what you want to use for your scaling operation. I've used CPU. You can use other things as well, but CPU is pretty straightforward. So I use the mon put metric alarm and give it a name again. Comparison for scaling up is greater than, scaling down is less than. We will set the number of evaluation periods. So this is when it starts to make sense whether you're using detailed or non-detailed monitoring. Your period will be limited by that. So if you want to scale more frequently than every 5 minutes, you'll want to have the detailed monitoring. So your evaluation period is in terms of that increment. One period would be 1 minute for detailed or 5 minutes for non-detailed. You can choose to have more than one evaluation period. Maybe you need to have high CPU for 10 minutes before you scale. Maybe you don't. Maybe you just want to scale as soon as it hits high CPU. So again, we're using CPU with the CPU utilization metric. The namespace, this is something that is specific to CloudWatch. We use the AWS EC2 string there for the metric. And the period is in seconds, not milliseconds or anything like that. So we try and make that coincide with the monitoring period, 60 seconds for detailed. If you used more than one evaluation period, you'd want to use probably something like average. In this case, that really doesn't mean anything because the average of 1 is the same thing as the number itself. In this case, I was a little bit confusing, and I used the threshold of 60% CPU to scale up, not to be confused with the period of 60 seconds. And then the alarm action is the ARN that we got from the previous step when we created the policy. And then the dimension is the auto-scaling group name, and it should just look like that, except the, whatever your group name might be. For the scale down policy, I used a threshold of 25% CPU. So that means that after 60% CPU for a minute, I'm going to add another server. And if I go down below 25%, I'm going to take away a server as long as I have at least one. So you'll never go down below 1 because I set a minimum of 1 server. So this is what we end up having, again, a load balancer in front of an auto-scaling group with 1 or more instances, talking to S3 as our shared content store and RDS as our shared database. So what does this actually do? And I think that's big enough for everybody to see. This is a screenshot of my AWS console. I've got some servers up and running, some servers stopped. I'm going to walk you through what would happen if I ran all those commands that I just gave you. First of all, I'd start up a server, just a single server, and it's going to eventually get to the point where it's running. And that time that it takes to start up, that's what your grace period is for. Once you start using that, maybe you hit that 60% CPU, you're going to add another server. And once you finish that extra demand, you'll scale back down and that instance will terminate. So what does that actually look like? This is the CPU usage on the first instance. You'll notice that the big spike is when it's starting up. It takes, I don't know, 8 or so minutes to actually get started up. Then I hit it with a bunch of tasks right there around 23 minutes. And that's way above 60%, so we should see a scaling action there. And then you can see it actually stops right around 34 minutes. So the second CPU, or the second instance that started up, you can see it started right there at 25 minutes. And then it kept going beyond when the 34 minutes where the other one stopped. So a little more detail on that.
Hey, Michael.
Yeah.
Sorry to interrupt you, but we've got maybe just about 5 minutes left.
5 minutes left?
Yes, I don't know if you want to start taking questions now.
Let me just, I'll finish up in just a second. So you can see there at 23, we've got a scaling action in the top graph, the yellow highlight. And then we've got another scaling action at 34. So that's the scale up and the scale down, and they coincide with the graphs above. Real quickly, some other things that you could do is a read replica on your RDS. That'll let you have higher read throughput, but not write throughput. You could do a replicating content store, kind of similar to a caching content store, but you've got your entire content store on your instance as well as in your S3. So it gives you a little more durability. If you wanted a hot spare, you could do something like Route 53 in front of 2 of these clusters. And once your active went down, you could go over to a spare. And finally, some future topics of study. CloudFormation templates would let you create all of this in a much more automated fashion. Elastic Beanstalk is Amazon's managed, basically Tomcat, their web server. Virtual Private Cloud, we talked about, well, I didn't talk about that, but it was talked about this morning. You can also use spot instances to reduce your cost with your auto-scaling group. That could be maybe a factor of 10 cheaper than using an instance. Or, of course, you could reserve instances. And then a lot of people are concerned about security, so content store encryption is another thing that you can do. We've actually done that for our own purposes as well as customers. So, questions?
It was really good. You basically got the rundown. Go off and do it now.
So obviously I don't expect you to absorb all that from this presentation, but you can download the slides. I've got a lot of references available. At the end of the slide presentation, you can go and learn more about each of these topics, RDS, VPC, all of these things that I've talked about, you can learn more about from either Alfresco or Amazon.